Hey everyone. In this episode, we are going to look at an exciting development for video detection applications, which can work across multiple CCTV sources to provide a comprehensive understanding of traffic movements, but without using facial recognition or ANPR to track pedestrians, cyclists, or vehicles as they progress through an area. Anyway, I'm Alistair, and this is That's ITS Now. Video sources have been used extensively for detecting vehicles for a long time. Originally, this type of technology looked for changes in the appearance of pixels within a predefined detection zone in order to signify the presence of a vehicle in that location. Although this gave a good proxy for vehicle presence, it suffered from reliability issues prompted by a range of factors, ranging from false triggers caused by shadows cast by passing vehicles to an inability to see objects reliably at night or because of harsh climatic conditions such as heavy rain, fog, or snow. The accuracy and capabilities for video detection has improved dramatically over the years, and the miniaturization of computing power has resulted in the ability to include a broad range of onboard analytics to operate within cameras, which is now broadly used in security applications to automatically detect anomalies. However, in traffic applications, the ability to provide flow data for traffic has really relied on the use of automatic number plate recognition, ANPR for short, to produce origin destination or OD data. Vehicle plate data is collected at sites around a road network and sent to a central location. Then the system will recognize when those vehicles pass other sites, providing information not only about where vehicles are traveling from and to, but also journey time information between these points. This type of traffic count information has been used for years by traffic engineers to understand the requirements of the travelling public by determining where vehicles are coming from and going to at different times of day and on different days of the week. This OD data is the base for traffic plans and timings used in the traffic management systems and traffic signals. It is essential that it is as accurate as possible, so the inevitable limitations of manual counts or route assignments pose issues for the efficient operation of a traffic system. In addition to offline traffic counts, OD data has capabilities for use within live traffic systems, where increased intelligence about traffic and journey times can assist with the efficient operation of real-time traffic management. This is particularly salient for active transport modes, where we currently lack the ability to predict pedestrian and to many extents cycle demand at signalized crossings and junctions in real time. Unlike vehicular traffic, where systems such as the SCOOT Urban Traffic Control (UTC) usually knows how many vehicles have just departed a junction, so that signal timings at subsequent junctions can be automatically optimized to respond to actual traffic flow. The vast majority of traffic signal installations only account for the presence of pedestrians once someone waiting to cross has pressed a push button. With the changes in the hierarchy of users, and to encourage people to walk or cycle, it is therefore increasingly important that UTC systems are equipped to cater more appropriately for pedestrians and cyclists, by understanding that all the people leaving a tube or railway station, shopping mall, office building, etc., will be arriving at a crossing in the coming seconds. So there are some technologies which can be used to some extent in this type of application, but these have tended to consist of monitoring the Bluetooth or Wi-Fi addresses of the mobile devices being carried by a proportion of people, or to use facial recognition. However, ANPR, Bluetooth, Wi-Fi, and facial recognition systems pose potential privacy or GDPR issues. So how can this type of monitoring be achieved without having to remove parts of the initial data collection to retain privacy? Some systems attempt to deal with this by treating each individual camera feed as a separate node, generating an individual OD dataset for that site, but with no intelligence about how these movements link through neighboring locations. So the technology we are looking at in this episode is produced by a company called Route Connect, which has managed to achieve these requirements without having to collect any identifiable information on vehicles, cyclists, or pedestrians, so it's not causing any GDPR issues. Their innovations in video analytics allow them to classify each moving object so that it can understand the difference between different types of users, such as cars, HGVs, cyclists, micromobility, pedestrians, etc. The system then looks at each individual object and applies an appearance descriptor, which can't be reverse engineered to track a specific vehicle or person, which is then used along with movement prediction based on the object's location and trajectory, and using learnt movements at the site from historic data to then track each individual target. In itself, this provides a high level of accuracy for data collection, but the really remarkable part of the system's capabilities comes when you then add additional camera sources to extend the area of coverage. The clever piece with this is that the cameras don't need to provide continuous coverage. The system can operate with subsequent camera locations further down the street and still recognize that the vehicle or person which just left the first image a few seconds ago is actually the same entity it is now seeing at the next camera location. It can therefore put together an OD matrix of movements without having to have complete coverage of a street scene. This means that for site data collection, it is possible to use existing CCTV coverage from traffic cameras and the like to stitch together to produce reliable data automatically, with a claimed reliability of better than 95%. The output data can also be exported in a range of formats, which for traffic counts help to make things more comprehensible for users, a lot easier than a spreadsheet of numbers.
Remember to hit subscribe for ITS now.
Good. So slightly different today. I'm going to have a chat with my friends at Route Connect. So we've got Mohammed bin Smail and Dan Harborn from Route Connect. And we're going to be talking about their really interesting AI implementation for detection across multiple camera sources. So, hi guys, how are you?
Very well, thank you. Thanks for inviting us.
It's really good to have a chat, and I think our viewers are going to be really interested to have a look at something that's slightly different. You know, you're really leading edge as far as the implementation that you're undertaking. It'll be interesting to understand actually what your technology is and how it's used, the use cases for this.
So when we first looked at where we could improve efficiencies in our cities, we ended up through, as we were saying, through a number of paths, that from computer vision, from processing video, we could gain an understanding of movement in a particular location. And that understanding could be used to better plan locations, understand how crowds are moving through these locations and so on. But there was a core capability that was missing across the solutions that were out there. And this is a cross-camera movement understanding. And what we mean by that is, if you've got a location covered by multiple cameras, you might have a pedestrian or a vehicle that moves across the view of one camera, leaves that view, and then appears on another camera. And traditionally, you can approach that in two ways. One way is, what you really want to get is the complete telemetry. You want to understand that was one person, one vehicle across all of the cameras it passes. And you can get that from either using automated number plate recognition or facial recognition. And that allows you to join up the dots, but then has privacy concerns, and then also has robustness concerns, because of course, if you're looking for facial landmarks or you're looking for a number plate, you need to actually be able to see that. So if the view of the face or the number plate gets blocked, or your cameras are low resolution and sort of just a bog standard camera, you might actually not be able to run those kind of what are pervasive technologies anyway on those cameras. So you have privacy concerns, you have robustness concerns from that approach. The other solution, or the other approach that's common in the industry, is to treat each camera in isolation. So you actually drop that full telemetry and you end up with disjoint segments of movement for each camera that essentially treat the vehicle, the pedestrian, as two vehicles, pedestrians, completely separate. And that can be useful for some cases. You can still get some understanding from just pointing a camera at a specific thing, a small location, a doorway, or whatever it might be. But really, you want full capturing of the movement over a location, and you want to, so you can do things like origin and destination. Where did a vehicle enter a junction, perhaps? Where did it leave? And making sure that's contiguous to get that full understanding. You might want to understand, perhaps at a station, how long is it taking for passengers to get from one station platform to another station platform, and that journey will take them from one platform down through the station and then back up the other side across multiple camera views. And so in order to do that, you need this cross-camera complete telemetry. And so that was where we started from. We saw these use cases and we saw this missing capability. We didn't want to go down the facial recognition route, obviously, but we didn't want to provide incomplete analytics either. So we spent 2+ years on R&D for trying to get this sort of cross-camera movement understanding without having to use any problematic technologies, and we succeeded, which was a bit of luck. So then, armed with that core capability, we then set out for understanding different markets, the markets we'd already identified, new markets, and then trying to build a scalable, robust, productionized product to put in front of our first customers.
It has been a challenge to find the right use cases to work in, because you have use cases that are too big and other use cases where it doesn't make sense for the industry at the time. So for us, we finally came to a good understanding of the challenges that traffic surveyors face in the industry. So to give you some context, traffic surveyors, the approach right now is quite manual. So they will get commissioned by local authorities, by property developers, by engineering consultancies to try to understand a location. And what they'll do is they'll put the cameras up, collect the footage, and with that footage, it will be sent to remote teams that are analysing, counting the videos to understand which way the vehicles turn. So a lorry that went left or a bike that went right, just one by one, and that's all they get. It'll be a spreadsheet at the end of it. It's quite a laborious process. It requires multiple checkpoints to make sure that there aren't any errors. And for us, what we can do with the core technology and the capability that we bring to the table is the ability to provide that understanding in a much, in a robust way across the junctions. And part of the challenges that traffic surveyors have is a lot of their projects sometimes require multiple cameras. So you need different angles to capture different parts of the junction. You might have obfuscation or blocking in certain areas. That's why they need multiple cameras. Or even within a single camera, you still get that obfuscation problem. And the capability that allows us to provide added robustness across multiple cameras also provides better robustness in the single camera view as well. So that for us is the first core element. Finding a market that's business to business, which is better than trying to engage on long sales cycles, especially for some industries. It can be quite notorious, the amount of time that you need to spend just to get your foot in the door. And so traffic surveying gives us a really good opportunity to get out there with a first product immediately. And then building on the top of that, being able to unlock additional capabilities with the ability to do real-time analytics. We were able to test that as part of the Zenzig program that we were on last year with Smart Mobility Living Lab in London. They've got a really good setup to allow startups to work with them and test their capabilities. And that gave us the confidence to look at then developing follow-on products. For example, how about replacing loops with virtual loops, an above-ground camera system, so that we don't have to dig into our roads and we don't have to worry about heavier vehicles damaging the installations. And if you need to replace it, it can be much simpler without having to close lanes moving forward and feed the data in the same way to the urban traffic management control systems. So that for us is a really key element to working towards smarter cities. And as we look at building a network of these, you can start to connect them together and pass on the data between them all. And providers like Unix will have already built systems and algorithms that help manage that, and we can feed into that sort of thing.
Yeah. We've been hearing recently a lot about AI, and there's a hell of a lot of scare stories, and there's a lot of hype about basically everything having AI now. I don't know when my first AI toothbrush is going to be, but I'm sure it's going to be pretty soon. So I think there's a lot of skepticism out there about capabilities and claims about how systems and products can work. So how do you actually guarantee that capability and the scope of what you're saying that your systems can actually achieve?
Yeah, absolutely. So I think this is a super important one for us because we have seen a number of computer vision based solutions out there in the market that are offering somewhat of what we do. It's usually single camera approaches, that kind of thing. But the feedback we're hearing from their customers and indeed our customers is that those that have tried the existing solutions have been a bit let down. And the reason for that is actually getting this right is a really challenging problem, and that's why the R&D we did took 2 years, and you need things like that to give you the robustness. What we've actually done is we've developed what we call the Development Partner Program, where we're working with traffic surveyors to, in partnership, they provide us with footage, they provide us with how they what's the project life cycle for a traffic surveying project and so on. So we get an understanding of the industry, we get data from them, and from that data of historic projects, we can process that and then look at our accuracies across those projects. So this is something we're actually really keen to get right because, as I say, because of those customers being burnt in the past, there is this skepticism around AI, and we're not looking to be someone that just says yes, it can do it, and then let people down.
So, with all of that sort of technical background, is that a key differentiator of Route Connect compared with your competitors?
Yeah, I can speak to the technical side. I think there's also a customer side to this as well. But yes, absolutely. So the way we've kind of worked with our development partners is we've worked with them to get that test footage, and then we've been honest with them about the results. So that iterative process is actually so. I'm kind of academic in nature. That's where my background is. So I love having a number that we're targeting, like a threshold and a number that actually directly correlates to a customer's need, and working on improving that metric and measuring it accurately. So what we can do over time is we iterate with the customers, see what there is, see the new challenges, and then be honest about where we're falling short and ask them for how we can improve and work with them to do that, which we've done.
Yeah. And to add to the customer experience side of things, we're finding that some of our competitors, they'll have slick solutions and they'll look good, but customers are intelligent. They will dig into the numbers and they will know and smell if something's not right. And they found that to be the case in a lot of cases. The issue can stem from the inaccuracies, and that can feed into inaccurate diagrams and inaccurate results as part of that. And some of the problems that competitors have as well is the way they set up projects or the systems get set up can be non-intuitive. And so how a customer uses the product is a different experience in itself, and the feedback that they provide is important. So we take feedback and work with the customer in an open and transparent way to try to understand what we need to do different about our development, whereas what we found with the industry sometimes is a feeling of status quo, and this is just how it's done, and this is how you have to take it.
From that sort of customer centricity, what does your system actually output? And what do you see the use cases for all those different styles?
From a technical perspective, in the manual process for traffic surveying, which is the current thing we're replacing, really only provides a counting spreadsheet of all the different turns. We obviously provide that. So we provide at the basic level, here's the count, here's the classified turning count for the location. What we also do is we then take the movement telemetry that we've seen at the location, and we can display that as desire lines, which can be coloured by each individual entity, so you get an understanding of each individual road user, or we can colour it by the classification of the vehicle, so you can get a general idea of the trends. And so that's quite useful in terms of seeing how perhaps pedestrians are walking across a junction, maybe where they're not supposed to try and get an understanding of how pedestrians are using a junction. But you can also get interesting insights. So we saw at Cardiff, there was a new bus lane put in, and that bus lane was in between the bus lane and the pavement was a cycle lane, and in order to get the pedestrians from the pavement to the bus when they're boarding, they put in a zebra crossing that the cyclists were meant to stop at. We saw in our desire line data that actually cyclists were going onto the pavement at speed rather than stopping at those zebra crossings. So these kind of things, and that project was a cross-camera project, so it wouldn't have been possible without the capabilities we had. But these kind of added visuals really bring life to the data, and you start to see patterns that you wouldn't have just done in number form. And then we can do things like heat maps, which show general trends over time, and even 3D models of a location, which are commonly known as digital twins, where you've got a replica of a location in a 3D space, and we can inject our data into that to help.
Yes, and the value to the end consumer is that capability to see things. So sometimes digging into the numbers can be difficult, and creating diagrams out of the numbers can also be quite laborious and difficult. And so we automate the creation of all of that. So with things like desire lines and the heat maps, you can start to figure out where people are crossing. You can filter by specific count lines, so you can even see if people are going the wrong way down a road, or entering a junction and cutting it more than needed, and that can have safety implications. You can start to, as we build on our features, look at near misses in the future. You can start to look at dwell times as well. So with the time lapse, you can see where people are waiting or where vehicles are waiting, and then where are they crossing or where are they going. So you can perhaps add in new crossing zones, or make the place much safer. And you would be able to see that more visually by being able to filter for these different types. And what's even more interesting is we build our portal and our solution so that customers can access the portal, and even the end customers, so the local authorities and the property developers, for example, they can start to see and decide how they want to slice and dice their data. So they will have access to the project and the output of the project, and they can select their own options for a particular time that they wanted to see, or a particular region, and hone in on that. And that'll be the power of what we can bring.
Yeah, well, I think, the manual counts are sometimes fraught with issues, so being able to have a comprehensive way of actually amalgamating all that data from disparate sources is a key element. Even with a lot of video surveys, the actual data inputting often is done manually from that, so you could then start to ramp up inaccuracies within the data sets quite quickly. And one person has assessed something in this video feed as something, but their colleague has assessed it in a different way. So yeah, I think having that consistency across all of those inputs will make a big difference to it.
Absolutely. Just to add to that as well, which is a really interesting point that you raise, is as you have projects, and especially more complex projects that have, say, a complex roundabout coming off of a motorway, and you need to study all these different arms and actually connect the dots, it adds even more complexities to keeping track of all those vehicles in a manual approach. And what that tends to do is either causes additional errors, or you have to take so much time, which is a bit more exponential, to do the tracking of those vehicles in that space. And so rather than getting your project back within a week, you're having to take out 6, 7, 8 weeks to do that kind of project. And for us, with an AI approach, it makes it, the way it scales is very quick. So we're able to connect the dots and generate the results to a good accuracy and get it back to the customer within matters of days.
So we've talked in a bit of detail there about sort of offline applications for count, classifying, OD, etc. You talked earlier a bit about real-time applications, so I'd be interested to see what your thoughts for the future are around that sort of element. From a personal perspective, one area that has frustrated me as an ITS engineer for many years has been that we've had comprehensive vehicle detection systems such as Scoot in our cities for donkey's years, but actually as the priority of users has changed, so the hierarchy that we now apply is that pedestrians and active transport users are at the top of that hierarchy, yet we don't have the same sort of capabilities for those users that we do for vehicular traffic.
Absolutely. So the ability for us to detect many user types and learn from that is key to ensuring that we can do the active travel detection and, across pedestrians, cyclists, e-scooters, and being able to prioritize those into new systems being developed to manage all types of users across the road space, not just the large metal lumps of vehicles that we have traditionally had to deal with. And so that's all part of the direction that we're heading in. We want to make our cities more efficient and have a more sustainable future. And the way we need to do that at the baseline is to have a really good understanding of how we move across the city. So, and as you say, doing that in a way that's GDPR, have confidence from people in that we're not using privacy breaking technologies is a really key aspect of that. And so for us, we've made sure that everything that we've developed is in a way that doesn't use any privately identifiable information.
It's getting a feel for the ebb and flow of traffic movement. So, you know, traffic isn't just vehicles, it is pedestrians, it's people going to and from work or to school or whatever. So being able to understand that and then actually incorporate it into UTC systems and traffic signals so that actually they're the set of signals down the road knows that there's a platoon, as we refer to vehicles, but of pedestrians who will be there in a minute's time or something, so that it's actually taking account of that in the timing cycle. Reading your technical literature, I was interested to see about the way in which you use both historic movement information to give you a prediction of where people, well, objects are going from, so where they're going to, and also the use of appearance descriptors to actually be able to fill in blanks between different camera locations.
This is part of the second step of our pipeline. So once you've got your detections of entities, be it or objects, should I say, so a pedestrian or a car or a cyclist or whatever it is, you've then got the second step, which is given that you've got a bunch of detections from previous frames of the video, does this detection belong to the telemetry of a person or a vehicle that you've been looking at previously? So the first step, as you say, to that answering that question is looking at the historic movement. So given the current telemetry for a car that we've been observing on a camera, where do we think that might be in future time, so that we can get a rough idea of where to look for that same car or pedestrian or whatever. And that works pretty well and gets you most of the way there. But there are some scenarios where it gets a bit more complicated. And for that, we use something we call an appearance descriptor. So this is unlike, with facial recognition, you've got a set of landmarks that are specific to a person, and you're looking for basically a fingerprint to give you the ability to connect the dots. We don't do that. We use an AI process that gives us nondescript numbers, 256 of these numbers, that we can then pair with that historic movement to say, given that we've seen a historic movement like this, and we've got a detection here, when we take the detection we've seen now and pass it through this AI and get these numbers, when we compare those numbers to the numbers we've seen from the historic detections, how close are they? And that provides an additional clue to this piece about connecting the detections together.
Just to add to that as well, you really do need to be careful about what is personally identifiable and what isn't. We've seen articles of people say they don't use facial recognition, and then they say they use gait, which, you know, is just as identifiable. Being able to take a finger, that takes a fingerprint. Height, for example, could be identifiable. If you have a 9-meter tall person and they're the only person, that is identifiable to them. So you really do need to be careful about understanding personally identifiable information in a really good way to not fall foul of GDPR.
Yeah, we've seen all sorts of illustrations of different types of technologies used for various traffic detection over the years, where suddenly actually they've had a data breach because they haven't, if they are collecting things like ANPR data or Bluetooth Wi-Fi addresses, they're not actually cutting them up in situ and pushing the data out in an encrypted manner. They're actually sending the whole data set out and then, oops. But it's interesting how attitudes to this sort of issue are so markedly different around the world. I was talking about this to some colleagues in America a couple of years back, and they couldn't understand what's the issue about this. They thought it was fine just to have ANPR data just squirted around all over the place, and couldn't understand our obsession with anonymity. So next 5-10 years, you've been busy for the last few years, but in 5 or 10 years time, where do you see this type of technology, the use for it?
Yeah, there's so many areas. There's so many areas that you can tackle with this, and for us it goes back to the core vision of wanting to make our cities efficient, and what are the aspects of that city. So smart junctions, so the road sector is the first port of call. Moving then into rail networks, so what can we do about public transport, buses, rail, as well as the retail spaces. Being able to understand crowd movements in many areas is quite important, and doing so in a way that's preserving privacy is key there. Events and event management, so you have so many festivals, you have so many conferences that people want to attend and want to understand where people are staying, and where in terms of the booths that they visit and the areas that they go to, and what they can do about alleviating crowd movements in those spaces between keynote speakers. And then you have other areas like construction sites, really busy areas for safety, being able to understand where people are or were, so that you identify any safety issues, or maybe there's certain times that people aren't supposed to be in an area, so that can alert construction sites to particular zones, and warehouses that have to deal with different types of vehicles, and sometimes the movement of those vehicles, and where vehicles were kept and where they need to be put. So there's all these different areas across the city that can eventually connect in a way to make the city overall a bit smarter and a bit more efficient.
Brilliant. Right, well, thank you so much, both of you, Mohammed and Dan.
Thank you, Alex. Thank you very much.
So I think we've probably all learned a huge amount there about non-contiguous video detection capabilities. Really fascinating subject. And I think this is an area that's going to grow and grow. So thank you to Root Connect for taking the time out to have that conversation. Right. If you haven't already subscribed to this channel, please do so. It really does make a huge difference to our ability to provide you with future episodes about ITS. A lot of you are watching us and not subscribing, so it would really help if you would do that. Thanks. Apart from that, hope you enjoyed it. I'll see you next time. Bye now.